Hey gentlemen, this is the second lesson video for solving inequalities with single variables. So the first slide is just some important facts. You need to combine like terms if it's possible. You need to get all variables to the left, all constants to the right, and then if you multiply or divide by a negative number, you need to flip that inequality. I'm going to be writing the word BAM next to that to make sure you guys remember that anytime it's negative and you multiply or divide, only when you multiply or divide, okay, do you flip that inequality. The bottom two are just so you understand, so if you see a less than or equal to symbol, it's the same thing as saying and in between two separate equations. And when you're done graphing, those two things would be facing towards each other. Okay? And if it's a greater than or equal to, that's or. And on a number line, those would be facing away from each other. Okay? So for the first examples, we have absolute value of 2x plus 4 is less than or equal to 12, and then 3 times the absolute value of x minus 3 is less than 9x plus 6. So for the first one, we get to go directly into those two equations because we are working with absolute value. So it's going to be 2x plus 4 is less than or equal to 12, and then 2x plus 4, negative 12. So I'm negating the right-hand side. You need to flip that inequality. Okay? Go ahead and subtract 4 from both sides on the left equation. So 2x is less than or equal to 8. Divide by 2. X is less than or equal to 4. On the second equation, subtract 4 just like we did the first time around. So 2x is greater than or equal to negative 16. Divide by 2. X is greater than or equal to negative 8. And remember, less than or equal to is the same thing as saying and you'll notice we're less than 4 but greater than negative 8, so this is facing towards each other. When dealing with a number line, please remember that you can, make it work for you. Okay? 2, 3, 4, 5, 6, 7, 8, negative 8. Greater than and equal to or less than and equal to means closed dot, and they should be facing towards each other. So for the second one, we need to isolate first, so you're going to go ahead and divide by 3. So that's the absolute value of x minus 3 is less than 3x plus 2. Then you're going to go into the two equations. X minus 3 is less than 3x plus 2, and then x minus 3, flip the inequality, negative 3x minus 2. Subtract 3x on the first side. That's negative 2x minus 3 is less than 2. Add 3. Negative 2x is less than 5. And then x, when you divide by negative 2, x is greater than negative 5 halves. And again, there's a BAM on that one. Okay? For this one, we're going to add 3x to both sides. That's going to give us 4x minus 3 is greater than negative 2. Add 3. 4x is greater than 1. X is greater than 1/4. Now, negative 5 halves, if you, were to plug it in,
Sorry, gentlemen, for the change in slide, but I had made a mistake on the last one. So for this one, it's important that when you do look at the negative 5 halves, if you were to plug it back in, you do actually produce a negative number. And since absolute can never ever be negative, that means that you do actually need to exclude that solution. So you're going to end up just having x is greater than 1/4. And then you would graph that, okay? So please make sure that you're paying attention to that. I had missed it, and that's why I'm fixing it now. So here are the u-tries. So 2 times the absolute value of x plus 3 minus 6 is greater than or equal to 4, and then 3 times the absolute value of 2x plus 6 minus 9 is less than 15. Please remember, okay? Sorry. Here is your guys' u-tries again. So again, left side is notes, this side is u-tries.